One of the key benefits that science presents to us is the ability to further humanity. One of the ways that science can do this is to prevent problems that society may face before they happen. In this spirit then, I am looking to the latest scientific research to help prevent a large problem that has been on our horizon for several decades now, an energy crisis. If we accept the situation of peak oil, which seems to be a reasonable assumption from the mounting body of evidence, the world's supply of fossil fuels appear to be an unsustainable energy source. An investigative report commissioned by the New Zealand Parliament in 2010 concluded that our situation was bleak at the very best. Oil production is unable to increase in the next 5 years despite a projected increase in the demand for oil. Also, as more easily extractable oil fields are used up, we must turn to more remote, deeper or otherwise unsuitable oil fields for our supply of petroleum. In the long run, the price of petrol and diesel can be expected to rise to the point where they are no longer economically viable as fuels. Well, alternatives to petrol and diesel are under development, but focusing on these that are able to replace petrol and diesel, there is no solution to an energy crisis yet. The main current alternative to petrol and diesel is biofuel. Biofuel is an alternative fuel produced from a plant that can be used in a very similar way as petroleum fuels are today. In New Zealand, our main biofuel is produced from a crop called rapeseed, or otherwise known as canola. An example of a commercial application of this type of biofuel is the Christchurch Metro bus system. In Christchurch, a large portion of the buses in the public transport network run on a biofuel blend. Although this is a very encouraging development, there is a large problem with the biofuel used. To begin with, rapeseed is grown, it is then harvested and processed to obtain biofuel, but this is then blended with normal diesel to produce fuel, which these buses run on. The blend used in these buses is called a B5 blend, and as it turns out, this consists of only 5% biofuel. Unfortunately, this B5 blend is the most common type of biofuel in use in New Zealand. Well, aside from the small portion of real biofuel in these commonly used biofuel blends, there is yet another reason why current biofuel technology has had a lacklustre reception worldwide. Whenever a crop, such as rapeseed, must be grown for the production of biofuel, land must be used to grow this crop. Unfortunately, this is almost always land that could have been used to grow food for human consumption. This is quickly becoming a large human rights issue. In 2008, Jen Ziegler, who is the United Nations Special Rapporteur on the Right to Food, said that biofuels with today's current production methods are a crime against a great part of humanity. Another large problem is the amount of energy that must be used to produce these fuels. As outlined by Nicole Foss on an interview on Radio New Zealand on the 24th of March, current biofuels will often yield less energy than what is actually used to produce them. The amount of energy needed to produce them is actually larger than the energy that they produce as fuels. All of these issues mean that biofuel produced from a crop dedicated to producing fuel will not be ethical or sustainable alternatives to petrol or diesel. I believe, however, that second-generation biofuels are an interesting and promising development. Second-generation biofuels are biofuels that, by definition, do not create a conflict with food production. Also, they are often easier to use by themselves as an alternative to petrol, and unlike rapeseed biofuel, do not usually need to be blended with petroleum to be used as a fuel. While I do not believe that one type of second-generation biofuel will have a chance of solving an energy crisis on its own, Several methods for the production of these biofuels may hold at least part of the key from freeing us from our dependence on petroleum. The first of the second generation biofuels that I would like to suggest today is cellulosic ethanol. Ethanol is the chemical name for alcohol, as found in drinks such as wine and beer. Pure ethanol, as it turns out, is quite desirable as a fuel. It has a very high octane rating. In fact, the American NASCAR races now run on an 85% ethanol fuel. Ethanol is in no way inferior to petrol. One new method for the production of ethanol is by breaking down cellulose. Cellulose is one of the most abundant substances in nature. It is contained in nearly all plant cells, and so makes cellulose a perfect starting point for the production of biofuel. The byproducts of the agricultural industry, such as corn stalks or wheat chaff, all contain large amounts of cellulose and are a perfect starting point for biofuel production. Also, a plant called switchgrass contains very large amounts of cellulose and can be grown in locations where traditional crops cannot be grown. The way in which cellulose is converted into biofuel is relatively straightforward. I'd like to give you an overview of this process. To begin with, cellulose is composed of glucose sugars. Typically, several thousand of these glucose sugars will link together to form one molecule of cellulose. But here are just 4 such glucose sugars. In a plant, these are bonded together to form cellulose. When we want to make biofuel out of cellulose, we must first break the bonds that hold these glucose molecules together. We can do this in a commercial situation with the use of the specialised cellulase enzyme. After these bonds have been broken, we are left with many glucose sugars. These can be then converted into ethanol by yeast. The ethanol produced can be purified by distillation, in other words, boiling off and collecting the ethanol produced. So, this process is able to produce fuel from otherwise underutilised byproducts, and it removes all conflict for farmland. It removes all food versus fuel debate. It would even be possible to produce this type of biofuel from green waste, which I have found particularly fascinating. And in the context of an amateur laboratory, I decided to give it a run and see if ethanol really could be produced from cellulose. Well, I found that I was able to produce measurable amounts of ethanol, but due to limits in time and equipment, I was unable to obtain as high a yield as I would have otherwise hoped for. It could be expected that greater yields would be obtained in a commercial situation. Interestingly, in the United States, the National Renewable Energy Laboratories have succeeded in establishing a small plant for the commercial production of cellulosic ethanol. They have found that it is possible to produce this biofuel for less per unit than petrol is currently sold for. One byproduct of interest from the production of this biofuel is a substance called lignin. Lignin is produced in this process, and it can be collected and then burnt to provide energy for the distillation process. This means that the starting matter can effectively power itself to be converted into biofuel. Another second-generation biofuel that I believe can also help to fulfil energy requirements in New Zealand is biofuel obtained from microscopic algae. These algae perform photosynthesis. In other words, they combine water and carbon dioxide to produce glucose and oxygen. Once again, the glucose is able to be fermented into ethanol. While this process may sound very similar to cellulosic ethanol, it has several differences that make it especially suited to production in New Zealand. Firstly, the algae absorb carbon dioxide, which is a known greenhouse gas. The ability of these algae to convert a known greenhouse gas into biofuel is very interesting. Trials done at the University of Melbourne have found it is possible to equip a coal power station with these algae to absorb the carbon dioxide produced and produce biofuel. Secondly, these algae produce biofuel directly. There is no need for enzymes to be used, and this lowers production costs greatly. There is even another more exciting application of this technology, however. Again, the University of Melbourne have found that with genetic modification, it would be possible to farm these biofuel in the sea, absorbing atmospheric carbon dioxide and producing glucose for use to be converted into biofuel. So we could eventually produce our biofuel in the sea while lowering atmospheric carbon dioxide levels. There is great potential here for a country like New Zealand that is surrounded by ocean. Another interesting use of this algae is to convert sewage or effluent into biofuel. The Christchurch Sewage Station has installed a system that feeds the algae on the carbon dioxide produced by the decomposition of the sewage. This technology could be implemented to produce fuel from dairy effluent, which is a major environmental concern in New Zealand. The processing of all our effluent and sewage in this way could yield us a significant quantity of sustainable energy and transform a product which is currently only a waste material into something that we can extract value from. So the technology of second-generation biofuels presents important benefits to New Zealand. The most obvious benefit from a transition to second-generation biofuels is that we can keep the country running in the event of an oil crisis. Of course, many things that run on petroleum would need to be modified in order to run on most biofuels, but the possibility of a looming energy crisis should cause us great concern. At all stages of our food production process, petroleum is a major input, and should that become scarce, then the consequences for us as individuals and as a nation are drastic. No matter if oil runs out in 10 years' time or 100 years' time, the reality is it is going to run out, and we must prepare for this now. Also, petroleum will need to be used to convert to biofuels. We will need petroleum to make the infrastructure for biofuels. We must therefore convert to biofuels while we still have the resources to do so. Regardless of a fuel crisis, we have the capacity to produce our own biofuel, whereas we currently rely on many other nations for our supply of petroleum. This means that we could have much greater control over fuel prices, which is one of the greatest drivers of inflation in New Zealand. Why not make our own fuel and control our own economy? Economically, New Zealand can expect to benefit from the availability of local jobs due to the production of biofuel. Eventually, a larger supply of fuel may be able to result in lower prices despite demand for fuel constantly increasing. Now, the government must take an active interest in funding projects to produce sustainable second-generation biofuels commercially, and needs to start implementing this technology for widespread use. We cannot afford to sit back until it is too late. Fuel shortages must be prepared for now if we are to have a seamless transition to second-generation biofuels. I'm looking forward to the day when the headlines proclaim the reducing ethanol costs rather than an increase in the petrol prices. Thank you.